Good morning, Dreamboat users. I want to give you a quick start on how to use the Koya SS Dreamboat repo so that you can quickly get going with training your own model. This quick start is not going to be about how to actually install the Koya SS. You can actually download it from GitHub. If you search for bmaltais/Koya SS, you'll be able to find a copy of the software. And then you can clone and you can follow the instructions on how, like what are the required dependencies and the installation steps to get going, up to the point where you actually go and you start the GUI to actually train your model. So you use this command python dreamboot_GUI.py, and this will get the GUI for the trainer running. So let's start there, and then I'll show you how you can use the GUI to train your own model. So we're going to go into the Koya SS folder. You can see that the VENV is already active because that's important. You need to activate your virtual environment so that it runs properly. If you just install it, then it's going to be activated by default. But if you go back after you actually closed everything, you reboot the computer, then if you want to use it again, you're going to need to run this command, which is the /VENV /scripts and then activate. And that's how you actually activate the virtual environment. So let's start the GUI. By Python, Dreamboot. I want to get the dreamboot.py, and this is going to fire up the GUI. And now the GUI is ready to load. So we're going to control click on that link, and this is going to bring the Gradio UI for the Koya SS trainer. So there's a couple of tabs. We're kind of going to go through the ones that are important to you, what you're going to need. So the first one is you need to use a source model, right? When you want to train something, you need to add something to a model. So there's a couple of options here. You can use the optional quick picks. Here you can use either the Stable Diffusion 2.1 base. You can use the Stable Diffusion 2.1, which is the 768 by 768 model. You could use Stable Diffusion v.15 or v.14. If you want to use the quick picks, then you just literally click on, let's say we want to train on the 2.1 base. It's going to fill in the 2.1 base pre-trained model name there, and then that's how you could start testing. You could also opt to use this file icon to open up, and then that's something you're going to notice, right? You've seen the actual pop-up window open behind the browser, and that's kind of a little bit of a limitations right now. The GUI pop-up windows will not open on top, so that you may have to go and fish for it behind your browser window, especially if it was maximized, you wouldn't see it open. So if you click on the button and it does appear to do nothing, then just minimize or move your browser window around, and then you're going to find it behind it. So going back there, you could go and pick, for example, a model. Let me go and get to my model folder, and you could go and pick one of the models you want. We're going to pick, for example, this one, 512 base EMA, so that would be a V2 model that I would open up, which is a CKPT form. And then obviously when you load your own custom model, you're going to need to specify what it is. Like this one is a V2 model, so I would have to make sure that I click V2, and it's not a V parameterization model because it's not the 768 by 768 version. So you have to specify what is the actual model name. If you use one of the quick picks, for example, if I disable that and I click on one of the quick picks again for this one, well, I guess a different one, so it's not this one. So now you can see it will actually specify the right option. So if I go into a 2.1 model, then it's going to say it's a V parameterization model with V2. It's all baked into those quick picks. But if you manually select a CKPT or a saved answer file, then you're going to have to specify what this model is about. So for this quick start, let's pick one of these default quick picks. So I'm going to go with the Stable Diffusion 2.1 base, which is a 512 by 512 trained model. And the next thing you're going to want to do is you're going to want to go under utilities. And this is where we're going to structure the actual folder requirements for CoyaSS, because CoyaSS has some fairly strict and obscure structure required to train, and this here is going to prepare everything for you, so you don't have to understand and worry about how to actually name the folders, structure the folders, and whatnot. So first is for the instance name that you're going to use. Usually it's a keyword that does not exist within the CoyaSS space. In the Stable Diffusion space. So you would pick something like ASD in this case, which is a token that is not really known within the model. And then the class, let's say we want to train like a person, we're going to use a class person, because let's say that token that we're going to associate with is a person. Training image, but I'm not here to give you like this speech about how Dreamboot works, and mostly about like how to use CoyaSS for Dreamboot training. Training an image. So where are your training image? So training image in this case are in my Quickstart folder, and they are in the in the subset folder that I have. So I've got a subset of 8 image for the training, so I'm going to use the subset folder. And here I'm going to specify how many repeats of those image do I want. So do I want 40 repeats? Do I want to train for 160 repeats? For example, in this case, let's say 160 repeats, because there is only 8 image. And 160 is sort of a good number for training on 8 image using CoyaSS. Regularization image. Do I want to use regularization image? Most of the time it is a good idea to use those when you train Dreamboot. So I'm going to go and pick the regularization image folder, which is going to be my person DDIM, because it's a person class. So I'm going to train on person regularization image. And I only want to repeat the regularization once. Then you specify your training the destination training directory, which is where do I want to create my CoyaSS structured folders. So here I'm going to go and click on this again. I'm going to go and pick something under my Quickstart. I'm going to call that, for example, new folder. I'm going to call it Koya training. So call it Koya training. And I'm going to go and select that as my destination folder. So now I can click on prepare training data. It should actually fire up, and it's going to tell you that it copied these things. It copied the subset to this folder, and it copied the person DDIM to this folder with the proper name being your token and the class name. So it's done creating all of the required folder structure. So now we are good to continue. So the next thing you want to do is you want to click on copy info to directories tab, because if we go to the directories tab right now, you can see it's empty. It needs to be filled, like what is the image folder, regularization folder, output directory. You could manually go and pick those up, but because we've used this Dreamboot folder preparation utility, we can just copy the info that was actually picked up by the config that we've typed here, and now it's going to fill the image folder name, the regularization folder name, the output directory where we're going to actually spit out the resulting model, and the logging directory where we're going to log, I guess, the training data. Next thing you're going to want to do is you're going to want to go under the training parameters, and this is where you're going to specify your Dreamboot parameters, like batch size. Like in my case, I have a fairly powerful card. It's a 3090, so I can do batch sizes of 8. If you have like a card with less VRAM, then you will probably want to keep that to 1. By default, the number of epochs, so how many iterations of the number of repeats that we have specified do we want to do? I only want to do 1. those are all the typical parameter that you already know, right? I'm not there to really teach you how to do drain boot, but more how to use this GUI to quickly get going. So you can go and configure like the different, like the learning rate scheduler. You can configure like the precision that you want, what kind of save precision for the model, the output model that you want, how many CPU threads per process do you actually want to actually use. This is calculated by the GUI based on your CPU reported information. So in my case, it's 12. What is the seed that you want to use for the training? What is the max resolution? This is an important one. You need to specify the max resolution of your image. So in my case, I'm training on 512 by 512 image, so I'm going to set the max resolution to that. If you were to use caption files, instead of using the actual instance name and the actual class name, you can use an extension file to provide the information. So it could be a .txt file or a .caption file. So in this case, we're not going to use that. We're going to stick with the folder naming convention for deriving this information. So we're not going to use a caption file. And then if you wanted to stop the text encoding partway during the training, you could specify percentage-wise how many percent of the training do you want to use that for. There's a whole bunch of options here that you can, if you don't want token padding for the training, you can specify it. If you want to use safe tensors as your model format instead of .bin when you use diffuser's model, it will save them as .safe tensors. Do you want to do gradient checkpointing or not? Do you want to enable buckets? I recommend that you leave this one on, because this is going to resize your image. If you don't enable buckets, if your image are not all of the same size, like 512 by 512 or anything like that, then you're going to get an error during the training. By enabling bucketing, it will ensure that all of your image fit within this maximum resolution space. Cache latent, using the atoms, use Xformers, those are all typical training config that you use. And this is where you are now ready to go. One more thing that's important, especially since we are using, as you can see, a diffuser based model, because it's going to be downloaded from Stability AI. We need to potentially save this as a different model, right? If you want to get like a CKPT file or a safe tensors file, this is where you're going to select what is my final output model that I want. Like I want you to convert that diffuser model that you're going to train on into a CKPT file. And this is going to create a last.ckpt file at the end. And because here we are using a V2 model, it's also going to create a last.yaml file that will be used by GUI like auto1111 to know what parameters to use when loading the model. So in this case, let's pretend we're going to want to use the CKPT version, or let's go with safe tensors because this is the new standard. It's safer, so instead of creating a CKPT, let's create a safe tensors file format. And then yeah, so here we go. So I'm just going to go back into source model here, or it doesn't really matter because the train model button is global to the UI. It's something that might change in the future, but for now I could click on train model. And then you can look at the outputs by going back here, and you can see here the actual command that the UI is using to launch the training train _db _fixed.py. So you can use that to copy this and massage it as well as if you want to use the CLI after the fact, right? So you can literally take that command and rerun it through the CLI using this accelerate launch, and it's going to start the training session just like it does here. So I'll let the training continue. So what it's doing right now, I guess it's caching all of the latents with the buckets. So as you can see, it's kind of calculating all of the image, and based on the number of regularization image that I have in my input, now it's kind of going to go and randomize and create a matching per image, then per regularization image match in a random manner such that the training is actually totally randomized. And it is now caching all of those latents. Okay, so now it's done caching, and as you can see, if we scroll back up, it actually created 2,560 512 by 512 latents for the training. Then it's going to go and start the training session. So those 2,560 steps, if you wish, will now be compressed to 320, because in my case I'm using eight parallel training. So I'm kind of using this option here under the training parameters to have like batch sizes of 8. So that's why this number now is going to look lower in here, because it's actually dividing this total number of training steps by 8, which gives 320. And now it's kind of slowly progressing, and that gives you an idea of the speed that I get on the 3090. It's actually sort of doing 1.2, 1. I guess it's probably going to stabilize down to something like 1.15. It's a bit slower because I'm kind of recording this at the same time, but the training is going to get going. So I'm going to pause this, and then I'm going to resume when the training is done. Okay, so we're almost to the end. So it took about 4 minutes and 35 seconds to complete the full processing. And now it's saved the model, and now it's converting the model to a safe tensor. So now, as you can see, it saved it as a last.safe tensors, and it's finally converting, saving the inference model. So we're all done. So now we have the model saved in half precision, and it's actually also has the required last.yaml file for auto to actually use it. Now let's give that a try. Let's see if it worked, because that's the whole point, right? We want to make sure that this model is going to work. So I'm going to go and fire up auto 1111. So let's go here into here to web UI user that. So let's actually load auto 1111. And while it does that, I'm going to go and make sure the model is in the right place. So let's go and open up the model location. So here, model should have been put under Quickstart, under the Koya training, because that's where we put. The model is now found under here, under last and last safe tensor. So this is the model. This is the YAML file. It goes in this here. If you wanted to use the diffuser version, this is the diffuser version of the model as well. Because we used the diffuser as source, it got created, it outputted originally or as a diffuser, and then converted to a last.safe tensor and last.yaml file. So we're going to go and copy those two things here. I'm going to dump them into my model folders. So models, I'm going to dump them. Let's create a new folder here, new folder that we're going to call it testing. I'm going to go here, put those two models there. And then let's go and open that up in auto 1111. So let's go up here, let's fire up that. Let's refresh so that we have those models available, and then let's go look at testing. So testing the last.safe tensors model, as you can see, it's picked up there. We're going to load it. And I don't remember exactly what we used as the it was ASD person. So let's go and use those two tokens to see if we can generate something out of there. And we're going to use ASD person. And we're going to leave the defaults for everything. We're going to make it like batch of 4. So we have like a sample. And let's generate something out of there. There we go. So we have the 4 different outputs for the model. I can show you the original inputs, which appear to match quite well with what was expected to be trained. So those are the actual outputs. And let's look at the actual inputs. So here under quick starts, under subset, and we can look at the actual, so we're going to view large icons. So we have like these typical image. So this is what the input is like. And you can clearly see that the resulting image are kind of matching the style of what was in the input. If we go back here, so you can see that. If we go back to the Gradio UI, you can see that we have quite similarly looking results. So that concludes how you can actually use Koya SS GUI to quickly prepare your folder structure, configure your training parameters, select your actual model that you want to train into, and then simply train your model up to the point where you can take the resulting files, put them into your Auto 1111 models folder or some other solution that you might be using, and use them as models for generating outputs. Hope that was useful, and have a great day, guys and girls. Bye.